What is broken access control? To know what broken access control is, we must first understand access control. Access control is the prevention of users from acting outside their roles or permitted actions. Broken access control is when websites and APIs do not sufficiently authenticate users, leading to unauthorized users acting out of their intended permissions, such as unauthorized information disclosure, modification, and deletion of data, and performing actions not permitted for the user. Because there are many methods to take advantage of this vulnerability, it is the most serious web application security risk according to OWASP, ranking first in their top 10 list in 2021. More details can be found on OWASP's website, and the link will be provided at the end of the video. One exploit that leads to broken access control is blacklisting. Blacklisting is defined as allowing everyone except predefined entities to access the resource. Consider this scenario: this is a restricted place where only Mary can enter, but Susan cannot. The instructions for the security would be, if the name of the person is Susan, they are not able to enter the place. Next, since there is no one else in the area except Mary and Susan, we can say that everyone else can enter the place, as Susan has been accounted for, resulting in only Mary left. This is a bad practice, as another person who is not named Susan, for example, Bob, who is not accounted for, can enter the restricted place. As such, whitelisting is a more secure way, with instructions such as, if the name of the person is Mary, they can enter the place. If the name of the person is not Mary, they cannot enter the place. From these instructions, only Mary and no one else can enter the restricted place. With this scenario in mind and bringing this into a web application perspective, blacklisting can lead to unauthorized users acting out of their intended permissions, which is the definition of broken access control. Therefore, whitelisting is a more secure method than blacklisting. Another exploit is the modification of input fields in forms, usually hidden, such as sign-up forms. This exploit can cause cross-site scripting but will not be the focus of this video. In this step-by-step process demonstration of a user submitting a form, web developers may make use of hidden input fields to provide extra information that they may not want normal users to alter to the web server. Firstly, the user, a student in this scenario, signs up with username Bob and password 123, and clicks the Submit button. With a hidden input field user type that specifies that this user account Bob is a student. The values supplied by the form are sent to the web server, where it handles the data and sends a SQL command to create a new student account Bob. When successful, the database sends a reply to the web server, and the web server sends a message to the client stating that the student account has been created. However, another person, an attacker in this new scenario, can change the hidden input field user type to specify that he is a teacher, even though he is not one. As such, a new account with higher authority has been created in the database, giving the attacker elevated permissions in the web server, potentially causing harm to the system. From this demonstration, we can see that hidden input fields are not secure because the user can manipulate the hidden input field's values. As such, web developers should specify the user type later in the process, either in the model or controller layer of the web server, or the database itself, in the form of a default value. Another exploit is the modification of request parameters in APIs. APIs are defined as a set of operations that allow applications to communicate with it. It allows us to manipulate and retrieve data in databases. All requests previously mentioned are API requests. Request parameters are values that are in API requests, such as metadata that includes cookies that save browsing information, and form input fields. They are used to send additional information to the web application. However, modifying request parameters cannot be fully carried out in the browser, and will need third-party software such as Burp Suite and Postman, which will both be used to demonstrate this exploit. In a normal scenario where a shopper pays for items, typical request parameters will be price, product ID, and user ID. The request, together with the request parameters, will be sent to the web application to be processed, and the user will be charged the indicated price in the request parameters. However, an attacker can use Burp Suite's proxy to modify the price in the request parameters. Burp Suite's proxy is one of the tools offered by the software and can intercept network traffic and alter requests. When the attacker sends the request via his browser, Burp Suite will capture the request, and he can use Burp Suite to change the price value. The altered request will be then sent to the web application instead of the original request. As such, the attacker is supposed to pay $100 for product 220, but actually only paid $1. From this scenario, we can observe that Burp Suite's proxy is best used when the request parameters or API endpoints are not known. Alternatively, an attacker can craft his own request using Postman. Postman is a software that allows the creation of API requests. Using Postman, the attacker can create and send an API request to the web application without the use of the browser and modify the price value, resulting in the attacker paying $1 instead of $100 for product 220. From this scenario, we can observe that Postman is useful when you know the request parameters and API endpoints, skipping the steps of ordering items, checking out, etc. in the browser. Similar to modifying input fields, these type of request parameters should not be defined in the client, and should be defined in the web application such as in the database. However, another attack that can be done in the same scenario is modifying the user ID, which allows the attacker to impersonate the respective user of that particular ID. In this scenario, the unfortunate user will be charged for product 220 instead of the attacker, but there are other outcomes such as changing the user's password or email without their permission. This is a bad practice as the web application does not effectively authenticate users and attackers can disguise themselves as other users and cause harm to the system. As such, JWT tokens can be implemented to authenticate users. JWT tokens, defined as JSON Web Tokens, is an open standard that defines a compact and self-contained method for secure transmission of information between parties as a JSON object. We can make use of JWT tokens to provide token-based authentication by performing authentication through logging in, and having our web service return a token that is saved in the user's browser cookies and can be used to authenticate subsequent requests that require authentication. Take note that JWT tokens are implemented in multiple solutions for broken access control but is not the solution itself. A JWT contains 3 segments: header, payload or body, and signature. All 3 segments are base 64 encoded. The JWT payload makes up the middle segment and consists of user-defined information. This can be used to prevent attackers from modifying sensitive or authoritative request parameters, as a JWT token will be needed for authentication and can be decrypted to expose unaltered user-defined information like the user ID, removing the need for sensitive request parameters to be stored in browser cookies. Without a JWT token, the system will drop the request and the attack cannot proceed. Another exploit is forced browsing. It is a brute force type attack that gains access to resources or pages that a web application does not reference, but can still be retrieved, such as insecure or unused APIs, web pages, and directories. A typical web application may have a file system like this. In a normal scenario, a URL a normal user will visit might look like www.mysite.com/menu. However, an attacker can change the URL to access more sensitive pages, such as www.mysite.com/secret. Without any authentication, attackers are able to access the page without any consequence and potentially cause harm to the system as long as they figure out the URL. The same applies to APIs, where instead of accessing pages from the browser, attackers can access APIs from Burp Suite's proxy and Postman. JWT tokens can be used to prevent forced browsing by implementing authentication middleware to validate the JWT token, securing web pages and APIs. Without a valid JWT token, the request will be dropped by the system and the attack cannot proceed. As APIs are used to acquire data from the database, the results can vary over time, such as the number of user accounts. When used together with a web page, the page will become dynamic with differing sets of data at two different points in time. A static page, however, can only display what was hard-coded into the HTML file, and may not include much sensitive data. As such, securing APIs is more important than securing web pages. Additionally, if a web page is heavily reliant on secured API requests, the web page will not be able to function as it normally would if forcefully accessed, and no sensitive data will be exposed. Based on the previous two exploits, we can observe that JWT tokens can play a vital role in a web application's security if implemented. As such, they will need to be protected from being stolen. One method is deleting the JWT token from the user's browser's cookies if the user has finished their business and has logged out. This prevents attackers from stealing the still valid JWT token from browser cookies and using it to impersonate the inactive user. Another method is to set an expiry time for the JWT token to become invalid once the set time passes, preventing attackers from using a JWT token they have stolen all the time. The last type of forced browsing is accessing directories. Using the previous scenario, like web pages, attackers can also access directories such as www.mysite.com/files if they know the URL. There are a few different methods to secure directories. Using Apache Web Server, you are able to edit the configuration file to prevent directory browsing. Writing code to prevent directory browsing in controller layer is another method. We have come to the end of the video. I hope you have learned something new about web applications and broken access control. Have a nice day.